Good evening. Hello everyone. How are you? How are you preparing for your Olympiad examinations? No answer to this question because hardly you got any time to be prepared for Olympiad, the next phase of examination. IOQM over, but school examinations are taking maximum time from you to get ready for those Olympiad examinations like RMO or the next step. Today's class I have decided to discuss principle of inclusion and exclusion with you, which is a very important topic for all mathematics based examinations including your JEE. But this class I am taking to help you for starting preparation on combinatorics for your mathematics Olympiad examinations. The principle of inclusion and exclusion is actually based on the concept of set theory. I'll assume that all of you are familiar with the basic concept of set theory, where union and intersection of two sets all of you know. The principle of inclusion and exclusion is the method to calculate the size of union of multiple sets. If I have two sets A and B, there are two sets, and for these sets, if you draw the Venn diagram, situation may be like this, where we have assumed that they are not disjoint. Initially, your problem is to find number of elements in A union B. This is nothing but NA plus NB minus NA intersection B. What you are doing there, you are finding number of elements. We can use the cardinal number symbol also. Cardinal number symbol means number of elements in set A can be taken this way, NA. Not mod A, this is for cardinal number. Cardinal number in A union B will be cardinal number in A, then B minus A intersection B. You want to find total number of elements in A union B. So when you are finding NA, all these elements taken into consideration. For NB, all these elements are taken into consideration. But this part, A intersection B, is taken twice. So we should subtract once to get number of elements in A union B. Now, if you are supposed to find, somebody asked you this question, how many elements are there that do not belong to neither in A nor in B? How will you find it? This is a case where we have found number of elements in A and B, total number of elements. Now number of elements nowhere in A and B will be what? let total number of points in sample space be n. Then number of elements nowhere in A or B is given by, you can write one more set here, A union B complement, its cardinal number. This is nothing but cardinal number of A complement intersection B complement, because if you have done set theory, you know A union B complement is A complement intersection B complement. So this thing how will you find? This will be total number of elements, from there we will subtract this thing, cardinal number of A union B. So cardinal number of this thing will be n minus cardinal number of A union B. This is nothing but n minus okay. So number of elements nowhere in A and B can be written this manner, n minus A minus B plus cardinal number of A intersection B. Very simple logic is there, that when you are finding total number of elements, they do not belong to A or B, you are going to consider this part, isn't it? This will be total minus number of elements in this union. Okay. What about three sets, A, B and C? Let me explain. If you consider number of elements in A union B union C, then you can find it from the Venn diagram, isn't it? This is A, B, C. Number of elements in this union will be number of elements in this set A minus number of elements in set B minus number of elements B in C. From there you have considered this part twice, subtract, 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 but this part is subtracted many times, that's why we have to add it once. So total number of elements in the union of two sets we can get this way. Now if I tell you to find how to get number of elements not belonging to A or B or C, because in inclusion exclusion principle this is a very important part where we have to find number of elements not belonging to neither in A nor in B nor in C. So from this diagram we need this part, excluding this. So if we want to find the cardinal number of this one, that is number of elements nowhere in A or B or C is given by total number minus, okay. So this thing we can find it by putting the value of A union B union C cardinal number n minus this thing. Cardinal number of A intersection C plus cardinal number of, okay. So this is nothing but n minus sigma E I equal to 1 to n. Before we do that, let me replace the set A by, symbolically we can write better form. A will be replaced by A1 and C by A3. Then A1, A2, A3. Number of elements nowhere in A1, A2 or A3. We can get n minus union of three sets, that is sigma ai I equal to 1 to n. You open the bracket plus sigma ai intersection bj I equal to 1 to n, j also 1 to n and I not equal to j. Ij this minus ai, to write this one aj, okay. This one ai intersection aj intersection ak ijk and not equal to k, okay. This can be extended for any number of sets to find number of elements nowhere in the union of three sets. Now this is the time to find some application. Before doing that, we must identify the sets involved in the problem. We will calculate the sizes of individual sets. Then we will subtract sizes of intersection of pair of sets, add back and sizes of intersection of triplets sets, and so on. So right now for three sets, if required, we will do it for many. Let us find few applications. Counting students who play sports. In a school, 30 students play football, 20 play basketball, 10 play both. How many students play at least one of the sports? You can use the formula directly. Cardinal number of this thing is required. They have asked you to do this part side by side. I am drawing the Venn diagram. They have asked you to find this thing. So cardinal number of A, cardinal number of B, and this part subtracted twice, that's why you subtract once only. I mean taken twice, that's why you subtract once. A stands for football, B for basketball. So number of elements in A will be there, number of elements in B will be there. from there intersection part will be subtracted once. So 40 students play at least one sport. Okay. Now the question arises this manner: if n equal to 100, I mean number of students in the whole set, this is universal set, that number we are taking 100. You find number of elements will not belong to any one of these. I mean, find number of students of the class containing 100 students where none of them play football or basketball. In that case, we need this thing. Or cardinal number of this set. This by formula we have seen n minus cardinal number of A, B and this thing what? Cardinal number of, okay. So then it will be 100 minus 40, that is 60. Clear? So you must know the application of both of it. Then overlapping events like previous one, 50 people like 30 coffee, 20 like both. How many people like either tea or coffee? Same way like previous one, cardinal number of people like tea, people like coffee, and from there we subtract the intersection, because again I am telling you this is taken twice. Okay, this is for coffee and this is for tea. Again in this class, suppose this is tea, no? Tea. Suppose there are 70 students. Find number of students they do not like coffee or tea. How to find it? In this case, again, I am just making you habituated with these symbols. This is nothing but n minus this thing which you have found, 70 minus 60, that is 10 students, they don't take coffee or tea. Let us see a problem which is based on 3 sets. In a group of 100 people, 60 like apple, 50 bananas, 30 cherries, 20 like both apple and bananas, 15 like both, 10 like both banana cherry, 5 like all 3. How many people like at least one of the fruits? This is direct application of this formula. Cardinal number of union from there C intersection A. This plus cardinal number of, okay. So that's why we have taken this stands for A, 60. This one 50, this one 30, 20. 15 like both, 20 like both apple and banana, 15 both apple and cherry, 10 both this and this, 5 like all 3. So we found A union B union C equal to 100. It is in fact given 100 people only. Question is, how many of them like at least one of these proofs? Answer will be the same. Don't be confused with the language. They like, just go by this. Whole set is being used here. This part for, oh, some common part is also there, sorry. This will be covered. Wait a minute. Because whole set I have to cover, so getting it in Venn diagram is a bit complicated. Universal set will not exist separately. No one outside. So better you take this diagram. A for apple, B for bananas, and C for cherries. So 100 is over. This one was 60, this one was 50, this one 30. Okay? So you got 5 like all, 10 both banana and coffee, so this part will be 5, and 15 like apple and cherry, so 10, 20 like apple and banana, so this will be 15. So this part is going to be 30. This one 25, so it will be 25. This one 20, it will be 10. Now if a question arises, how many of them like only 2? What will be your answer? Only 2 means this portion 15. 15 is actually what? Just cardinal number of, from there, if they like 3, this case to be subtracted. Similarly for this part and this part. So number of people like two of them will be what? That cardinal number of A intersection B. From there, this has to be subtracted. Okay? Then cardinal number of B intersection C. But again you are taking that part, so you must subtract. And for this part, so this is going to be minus, alright? Hope you have understood. Now put these values, you will get it from there. Okay? Go through this sum. In a group of 100 students, 70 speak in English. So, cardinal number of English 70, 60 French, and Spanish 50. both English and French. How to write this? This will be ten, and cardinal number of intersection they have given, they speak all three. So this is going to be 5. Okay. Your problem is to find how many speak at least one of these languages. You can find it easily, like that only. Just cardinal number of E, F, S, and from there you subtract this and add this. Clear? Just check whether it's matching or not. So this is going to be what? 70, 60, plus 5. So 180 minus this data I am changing a bit because I did a mistake over there in copying 200. So 180 minus 135. Okay, language may be French, English, Spanish, we don't know. Maybe some other language is also there. So if they have asked how many students speak at least one of the language, this is the answer. But then how to find number of students do not speak in English, French or Spanish? Then that is going to be given by Spanish we have taken by the letter S. Okay, this will be what? Total number minus, I hope you have understood, it will be 200 minus 65. No need to do this kind of sum again and again, because these questions I am going to share with you, we will do it later. I am going to discuss the dearrangement problem by using, and then obviously application in number theory. By using this PIE, let us solve derangement problem. Okay, what is that? See how easily it can be done with the help of PIE. It's very easy. This is just dearrangement of 5 objects. Can be done it for 4 objects also. But this time, if you have taken the sets in this manner, A1, A2, A3, A4, A5, remember you are going to find cardinal number of this thing you are going to find. If you go by that formula for 2 or 3 cases, initially it is what? Sigma mod ai. I mean summation of cardinal number of 3 sets or 5 sets 1 to 5. Clear? And this has to be subtracted from n. Okay? From here you will subtract the case okay, then you will add this thing. I am telling formula, then I will explain the concept. Do it for 3 sets. I, j, k, you take ai, aj, ak. Okay. Then this minus I, j, k, l, cardinal number of I, j, k, l, and then the last one I am extending for 5 plus sigma I, j, k, l, m on it, and they are not equal on this thing. This we are going to find. This is basically, if we explain logically, it will be what? It will be n minus sigma ai, okay, plus sigma ai aj minus sigma ai, I mean intersection, ak, plus and so on. So for 5 objects, when you are going to find number of rearrangement, you have to understand the meaning of rearrangement first. We will be using this formula, but by understanding the meaning of rearrangement. Let me explain. Letter envelope, letter 2 envelope 2, letter 5 envelope 5, okay. Then your problem is to find how many ways letters can be arranged so that all letters will go to wrong envelopes. Understand what I said? All letters will go to wrong envelopes. How to find it? So what you will do here, you will assume that L1 will not go to E1, but it can go to E2, E3, E4 envelope. These are for envelopes and these are for letters. You are placing letters to envelope. By mistake, all goes to wrong envelope. How many ways it can be done, that we are discussing here. Okay? So E1, E2, E3, E4. This letter 1 will just not go to E1. This is E5. it has gone any one of these four cases. For simplicity, let us calculate this way first. This formula I remind you first. This is called C formula. Name after this mathematician, where we are going to find none of the number of elements belonging to nowhere in A1, A2, A3, A4 or A5. Okay? And I have shown you what way we are calculating there. Isn't it? Just taking their total number, from there we subtract this, like this. Okay? Or by this method. Continues this method. So here, rearrangement for letters, it is similar meaning. You are just taking the cases where none of them goes to correct one. Okay? Now let us solve the problem this manner. Total number of, assuming there are in letters and in envelopes. Okay? Total number of cases, the way you can place letters to envelopes, total number of ways will be factorial n. Okay? You are going to find the element, that intersection of these cases. This will be total number of cases minus total number of cases minus when one letter goes to correct envelope. One letter goes to correct envelope. There may be case two letters have gone to right envelope, that you have to subtract from here. That's why minus two letters goes to correct envelope. But this excludes the case when three letter goes to, so bracket, see the use of bracket, minus three letters goes to correct envelope. But again bracket, this you have to exclude the case when four letters goes to wrong envelope. So huge total number of cases factorial n. One letter correct means that is correct, but others are incorrect. So others arrangement will be like this. From there we will subtract this case. Two letters in minus 2 factorial. Hope you understand. But this excludes the case where 3 goes for correct. NC3 factorial n minus 3. This way it continues. Let us simplify it. Just write this will be plus and this way factorial n minus factorial n. This thing is what? Del factorial n by 2. Next one will be plus, so there it will be n factorial continues this way. This is derivation cases. So we have started with, for 5 letters. For 5 letters it will be okay. So this thing going to be what? Factorial 5 1 by 24, isn't it? So just simplify it. This is what? Factorial 5 by 2, 60 minus factorial 3, 6. So factorial 5 by 6 44 cases of rearrangement will be there. Okay. Now another kind of application may be there by using this principle of exclusion, inclusion and exclusion. What? The question is something like this. I make it bigger for you. Yeah, read the question now. How many integers between 1 and 100 are divisible by any of the primes 2, 3 and 5? Okay? And how many are not divisible? How to find it? Read the question, try yourself first. Can you solve? Divisible by any means at least one of these primes, 2, 3 or 5. So let us answer this manner by using PI. So you find A1. A1 is the case where number of integers divisible by 2. This is 50. A2 stands for what? This is called greatest integer function. I will be discussing with you very soon in details about this function again. This is GIF. This will give us the integral part of this division. 33.33, we take 33. A3, number of numbers divisible by 5. Got it? Now the formula we are going to apply for this, divisible by one of them, state this formula: A1 union A2, their cardinal number. So this will be A1 cardinal number, A2. From there we will be subtracting these cases. This plus isn't it? So we need to find this. We found cardinal number of A1. A1 denoting number divisible by 2. Similarly A2, A3. But we need to find A1 intersection A2 also. How will I find? Divisible by both A1 and A2. Let us find it. Cardinal number of this will be 100. LCM of A1 and A2 is 6. That is 16. A2 intersection A3. This will be what? 100 by LCM of 3 and 5. So this is 6. And then A3 intersection A1. This will be 100 by LCM of 2 and 5. This is 10. And the last one, this cardinal number we have to find. A1 intersection A2 intersection A3. Like that only. Let us find cardinal number of A3. This is going to be 100 by LCM of 235, that is 30. So 3 point something, its modulo will be 3. So required answer is 16, 6, 10, sorry, 50, A1 cardinal number, A2 cardinal number, A3, then this thing you subtract, plus 3. Understood? Let us find its value. Okay? And know how we are asked to find, then you will be doing which is nothing but 100 minus this cardinal number of. Okay? So this class I have explained the basic concept of principle of inclusion and exclusion. You need to practice many sums based on it. Next session I will show you many application on it.